Okay.
Question. Do you fill a list?
Oh, yeah. There you go. You're welcome. Thank you for saying something. Okay. Wow. So. So we already kind of introduced this idea, right? We've been factoring since at least the last unit, right, where we were factoring quadratics, but now we're just kind of expand our horizons to any polynomial, okay? And this factoring polynomials, all right, we're just going to be like adding, you know, I don't know, strategies that we can use to factor polynomials, but there will still be polynomials beyond this that are factorable, but we won't have techniques to factor them. Okay, so like there will be polynomials that can be factored, but these techniques won't apply to them. Like we won't be able to use them. Okay, if that makes any sense. So like we're gonna still like these will not cover everything. So we're kind of like going a little more out into the wilderness, right? We were kind of in a safe place of the quadratics where we could like easily determine, well, if this thing factors or if it doesn't factor, and then we're done. But now we're going out into the more, crazier reaches of the polynomials where maybe it does factor, but any of the strategies we have won't work. All right, and then eventually we'll get to guessing and checking factors, okay, for our polynomials too. But that will be for a later date, not today. Okay, so we can just use our strategies and go from there. Okay. So we have a couple strategies, like I said, we talked about already, right? So some, factoring strategies from before. Okay. All right. What's our main number one first strategy we should always try whenever it comes to factoring polynomial? Greatest common factor. GCF. Okay, always look for that first. Okay, that should be the first thing you should always go to because it just gets the numbers smaller, makes it easier to work with. All right, after GCF, there's not really a hierarchy. I will say it's more of like you want to pick the tool that fits the situation kind of thing. So I'm just going to list these by numbers, but this is no more a hierarchy, right? Really, one is one for sure, and then after that, it's just kind of like a list of other strategies. So, for example, we can factor like a general trinomial, okay, using AC or guess and check. Okay, so using AC or guess and check, right? And I won't review that unless you need me to. I'll be happy to help you out with that some. Okay. We also had some like special situations too. I mean, for example, if we found a perfect square, right? We typically, created these when we were completing the square, but sometimes we run across it, So, and this, I'll give you an example for this one. X squared plus 8x plus 16. You don't really need to recognize this as perfect square because your general trinomial strategy will still work, right? So it's not even necessary to identify this, but anyway, this does factor, right? What does it factor to be?
X plus 4.
Yeah, x plus 4 and x plus 4. So in other words, it's x plus 4 quantity squared. Okay. So that's another, it's a special one, it's named, right? And we also talked about difference of squares. We used that in the warm-up. Okay. So, for example, I'll do an example of that one here. 9x squared minus 1 is 9 a perfect square? Right, yes. Is x squared a perfect square? Is x squared a perfect square? Yeah, right. It's the perfect square of x, right? So 9x squared together is also a perfect square. Okay? And is 1 a perfect square? Yeah, so 9x squared is a perfect square, 1 is a perfect square, and we are subtracting. It's a difference, a difference of two squares. And so this will factor. So there's our, a squared minus b squared here. So then what will this factor to be? 9x squared will become what here and what here? 3x and a 3x, yeah. And then 3x what? Well, we have to have a plus 1 and then a minus 1 there. Like that, right? And it factors there, just like that. Okay, if you don't see it, remember you can think about this 9x squared as the quantity 3x squared minus the quantity 1 squared there. And so our a is 3x and our b is the 1. And so there's our a plus b and there's our a minus b right there. Okay. The a is 3x. The a squared is 9x squared. Right? So there's a squared, 9x squared. So the a would just be 3x. The b squared right here is 1, so the b would just be 1. Okay? Questions on any of that? All right. Here's a few for you to try. I'll give you one. I'll just give you one. All right, so you try this one on your own. 4z to the 4th minus 16z to the 3rd plus 16z squared. I put the little tail there, or whatever, the line in my z, so that way they don't look like 2's. Okay? But now they look like some strange z. But you can write your z's however you want, but that's how I write mine. Okay. So, factor completely. Don't look at take it. Choose all at once. Take out piece by piece. Okay. So, if you're going to divide by 4, that's fine. But where does the 4 go? Right? When you divide by 4, you don't have like another side of the equation here for you to also divide by 4. So when you divide that 4 out, that should come out front. So 4 in front with the parentheses around this. You're pulling out the 4. It factors out. It's still there, part of the problem. You want it to still be even. I see you about 4z squared, right? You have a z here, you have a z here, you have a z here. So can you take out another z? So like I get like keep it right there and see if you factor that anymore. Okay. For factor completely, convince yourself that you can or cannot factor any further. All right. So be careful, right? This way. What you're going to do is your next step. That's very cool. You were just looking at the same. So that was so when you factor this, you divide by 4. The problem is you now have to change the value of this. Right? Get this equation. You could just divide by 4 and then you can divide by 4 on the other side, that balances it out. But when you divide by 4 like this, you change the value of this. What you do is put 4 in front with parentheses. Right? And then that means 4 still there. So you're right. Just put parentheses around this to the formula.
I know. That's what I'm saying.
You see, this is now
I saw JC after I and then from there I just had to
okay, good so far. Okay, good. Remember, if you wanted to, you put those together. Just make those 2 squared, but you don't have to. So you got a 4 so far. Make sure you pull it out front with parentheses and stuff. So you make that. That's good. You have that on your own?
Yeah.
Okay. Nothing. I'm just gonna let's see if I can. They both get the same score. 93 servants. It's gotta be. It's gotta be. Because the other two that aren't here. That's why. Thank you. Do I? You got any blue raspberries in there? Yeah. Raspberry. Didn't you call that? So back in the day, they used to make pink lemonade gelations. Those were delicious. They don't make them anymore, but they're delicious. Yes. Right. You've had like three. I don't want to touch it. Actually. Which one do you like? 4 out of 16. Which is that? You're what? I don't like these. You should go to them.
Yeah, let me put it
Break it back to 4 out. And then I'll go back. There's still stuff in X. Okay. Let's take a look here. Woo. Okay, let's go to Brook H. Brook H. What were we able to factor out here? A 4. Okay, so yep, we can take a 4 out. So a 4 and a z squared. You want to do all? Okay. 4z squared. Okay, so we take the 4 out. We're going to have just a 1 now, right? Z to the 4th, take out a z squared. That'll be z squared there. Divide negative 16 by 4, minus 4. Divide z cubed by z squared, we get a z. 16 divided by 4, 4. Z squared divided by z squared, gone. So there is our GCF, right? Is there anything else in common here, Brook H, that we could take out? Any more GCF? No, there is not. Okay, there is not. Okay, there's no. These have z's. This does not. These are both divided by 4, but this one's not, or divided by 2, but that one's not. So we're done with that. Okay. Did you factor any further? Okay, it does factor further. Let's go to Megan D. Were you able to factor further? No. Okay. How about Claire is in the bathroom? Hang on, Christian. We'll come to you here. Look at one more person. Chance. Matthew. Were you able to factor this any further? Trying to figure out. Oh, right. I remember that. Okay, Christian, help us. Christian.
Then I found what adds to get negative 4 multiplies to get 4.
Yeah.
4. And then I got negative 2.
Yeah.
So my final answer was 4z squared, then in parentheses z minus 2 squared.
Yeah. So, yep, you can write it like this if you want to, right? So the z squared minus 4z plus 4 factors to this. You still have that 4z squared out front, right? Don't lose that. That's all part of the problem, okay? We are not in an equation here. So we can't like divide 4 on both sides. Whenever we divide that 4 out, it's still part of the original expression. We have to keep it. It comes along for the ride, right? Same thing with z squared. You pull that z squared out, it still is along for the ride. You then just consider this polynomial here in parentheses to see if you can factor it further. And it does to this. Or as Christian correctly said, you could also say this, right? Because it's z minus 2 times z minus 2, so it's z minus 2 squared. And that's our answer. Either one is fine. I'm okay with either one of these, really. These are either one is okay. It is good recognized it does make a perfect square. All right, questions on that? Yes? The exponents? Okay. So, like when we were factoring stuff out, you mean? Like in the first step that Brooke did? Yeah. Like here to here? So, we take that, so do you agree at least that we can take out a z squared? Like you see that we can take out z squared? Okay. So when I factor out a z squared, factoring is a division. I mean, we are dividing it out. Okay? So I have z to the 4th divided by z squared, which is z times z times z times z over z times z. And then you can see, whoop, whoop, z squared is what's left over, right?
Oh, so subtract.
Yeah, exactly. Just like when you multiply, you add the exponents. Consequently, when we divide, we subtract the exponents. That's what it is. All right. Any other questions there? So let me show you a few more factoring patterns that we should be able to do too. Okay, so some new factoring patterns. All right, so we already talked about some of these perfect squares, difference of squares. Well, it turns out there's also a sum of two cubes. Okay. So that would be a to the third plus b to the third. Okay, and that factors to be a plus b times a squared minus ab plus b squared. Okay, and there's a difference of cubes. A to the third minus b to the third, right? Difference of two cubes. And the good news is that the letters do not change at all over here. It's just the signs. So for a sum of two cubes, we had a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. What's going to change here now with minus is that all these signs, okay, well, not all of them, but some of them will change, right? So the a plus b becomes an a minus b, okay? And then this becomes a b. Shoot, I messed up. Well, I can. Nope, it's not going to work. Messed up. A to the third. You guys need to rewrite the whole thing. I do because I have a pen. I talk too much. Always positive. I guess I was right. Anyway, I fixed it. Okay. So sum of two cubes, difference of two cubes is how it factors. This remaining quadratic will never factor, so you don't even have to worry about trying. The leftover quadratic here, this remaining quadratic, right, it will never factor. Or it won't factor like a quadratic. I guess there might be a GCF. But no, not in fact a GCF out first. That shouldn't happen. So never mind. Okay. So let's do an example here. I don't know. Let's try. We'll do two of these here. How about like x to the third plus 64? Excuse me. Okay. So don't forget your earlier factoring strategies. Is there a GCF here? No, right? You can't. This has x's, this doesn't. This has number 64, but there's no number there, so there's no GCF. Okay, it's not quadratic, so we can't use any of the quadratic stuff like the AC method, guess and check. We can't use perfect square difference of squares because these are not squares. Well, 64 is perfect square, but x cubed is not, right? So anyway, yeah, we gotta stick with something else here. So this is a sum. Is x cubed a perfect cube? Right, it is, right? It's x to the third, right? And is 64 a perfect cube? Of what? 4. Okay, so it's x cubed plus 4 cubed. So in other words, x is like our a, and 4 is like our b, right? So then the format here, how this should factor, is going to be a plus b. So in this case, it'll be x plus 4, because x is a, b is 4 there. And then it'll be a squared, which means I will write what? Yeah, x squared, right? If x is a, then a squared will be x squared. Minus ab, what will ab be in this case? 4x. And then b squared is going to be what? Plus 4 squared, which is also 16. Yeah, and there it is. There it is factored. This, like I said, this remaining quadratic here should never factor.
With the sum of two cubes, why is it a squared minus ab if there's no negatives?
here to say. I do not have a derivation for this yet. Like later, I'll be able to show it to you when we talk about dividing polynomials, or when we talk about dividing polynomials. Actually, like Monday, I'll be able to show you that. If you want to at least check, you could multiply this back out, and you'll see that it will cancel out and give you the x cubed plus 64. So if you do multiply back out, I promise you, multiply this out, it will give you that, all right? Just from what we talked about yesterday. So. Okay, but I can't show it to you necessarily until we talk about dividing it. All right, let's do another one here, and we'll do this one together as well. (16) z to the fifth minus 250 z squared. I want to make sure. Can I scoop this up? Is anyone still copying the sum of two cubes, difference of two cubes stuff? All right, I'll at least scoop it up to here. Okay. Is 16 z to the fifth a perfect cube? No. Is 250 z to the second a perfect cube? No. So we give up then, right? Because it's not two cubes. So why am I putting this here in this section? Well, what could we do first here before we start trying to use some other method like our sum or difference of two cubes here? Yeah, go ahead, Paige. So that say what?
You can take it as z squared.
Take out z squared. Evelyn, what were you going to say? Same thing, z squared. Okay. We can take out a little bit more than z squared, actually. What else? Go ahead, Max. A 2, right? Because these 16 and 250, that also divides by 2. So let's go ahead and take out our GCF. But again, if you saw the z squared there, that'd be fine too. But let's take out a 2z squared. Okay. So we get 8z to the third, okay, minus 250 divided by 2, 125, right? And then take out that z squared, it's just 125. Okay. Is there anything else we can take out in common to both these terms? Is there anything else we can factor out here that's in common to both? Like another more common factor?
Of 4.
So 8 does divide by 4, but if you look here, 125, that ends with a 5. So it doesn't divide by 2, so it wouldn't divide by 4 either. If it's something that doesn't divide by 2, then it won't divide by 4 for sure. Not evenly, at least. So the 4 would come out of 8, but I don't think 125 goes by 2. Or 4, I mean. So, is there more to factor out here? GCF-wise? No. Okay. So, now let's recalibrate here. Is 8z cubed, is that a perfect cube? It is, right? And I'll write it out here, 2z squared. 8z cubed is 2z quantity cubed, right? Is 125 a perfect cube?
Nope.
Of what? 5, yeah. So there's our A, there's our B. Okay. So, A cubed minus B cubed factors to A minus B, so it'll be 2z minus 5, right, times, and then A squared. So 2z is our A. So then what would A squared be? If 2z is A, what would A squared be? Sorry, go ahead. 4z squared, exactly right. Okay. AB, right, is our next term, so plus A times B. A is 2z, B is 5, so what's AB going to be? 10z, yep. And then B squared, well, if B is 5, what will B squared be? 25. Okay. Whew. And then we're done.
Why can't we just do the 2z squared times 2 minus 5 parentheses cubed?
Ah. Let me finish writing this out here. Okay, so Slayman asks, why can't we just say this is then going to be 2z squared times, you said 2z minus 5 cubed, like that? right? So let's take a look, right? So if I do 2z squared, and so this would be 2z minus 5 times 2z minus 5 times 2z minus 5. Okay. So if you were to actually multiply this out, okay, which it's going to take us some time to do that, and I don't want to take all that time to do it, we will not result in 16z to the fifth minus 250z squared. Let me come back to that at the end, and I will show you. Okay. But yeah, if you were to take the time to multiply that out, it would not multiply back to this. Okay. So if you actually cubed it, it would not multiply back to this. When you have a difference of 2 cubes, this is how it will always factor. Okay. So it won't work that. And I'll show you here. I just don't want to take the time because it's going to take me some time to multiply it out. But I'll do it later, okay? I promise. All right. Questions on any of the other perfect cube stuff? All right. We're just excited to be here, Mr. Whitmire. I know, guys. I'm very excited. All right. Yeah, let's keep going here. All right. So the other thing I wanted to look at was, did I talk about factor by grouping? Yeah, there we go. Okay. So another strategy, factoring by grouping. Okay. Again, something we've already been doing. Okay. I will give you a little clue here. It requires an even number of terms. Okay, we're factoring by grouping. And typically, you want the polynomial in standard form. Okay, so 2 little tips there for doing this factoring by grouping stuff. Which again is something we've already been doing when we use that. If you use the AC method, it's something you already do, right? So I'll just give you one example of this one. Okay, again, factor completely. So again, for those of you that like to memorize one way to factor something and then use that every single time, you can't do that here because different problems require different tools. So you will need to be familiar with all these different techniques and apply them when appropriate. Okay? I mean, for example here, you can still kind of go through your list, right? You kind of make a list for yourself. Is there a greatest common factor we can take out here? No. Okay? Is this a quadratic? No, so we can throw out all of our quadratic stuff. AC method, difference of squares, a perfect square factoring. It is cubic, but is it a difference of cubes or a sum of cubes? Like x cubed is a perfect cube, but we have all these other terms here, okay, that would not allow us to factor as a difference of cubes or a sum of cubes. So that won't work either. It also is not in like quadratic form, which is like what I was showing you guys here with that number 3 that we did for the warm-up. But again, we'll see one like that in the future. So in other words, we're kind of stuck. But we do have an even number of terms, and let's see if grouping works. Just because you have an even number of terms, by the way, doesn't mean grouping works. It's a strategy you can at least try here. So let's group these first 2. We'll group these second 2 together. From this first group, now look at the GCF for this group. Okay? So in this first group, what can we take out? Okay, how much? Yeah, what's the GCF we can take out here? X squared, right? Yeah, x squared. Okay, so x cubed taking out x squared leaves us with x to the 1, or just x. 3x squared taking out x squared leaves us with 3. Okay. What about from this group right here? What's the biggest thing we can factor out from the second group? So 8 works, but also, 16 is even bigger. In fact, I'm going to factor out a negative 16. And then we'll be left with an x. 48 divided by negative 16 is negative 3. Okay? You know factoring by grouping works if you were able to get the same leftovers, right? So we can take that x minus 3 out, and we're left with x squared minus 16. Okay? And so there was factoring by grouping. Okay. So we're done, right? No? Why not? Paige, go ahead. In this particular case, we resulted in a difference of squares, which further factors to x minus 4, x plus 4. So again, be on your toes there. Always ask yourself, can I factor further? Can I factor further? And yes, in this case. Because the directions say factor completely. Okay. All right, let me give you one of those grouping ones to try. Okay, same directions, factor completely. I'll leave that example up there for you. All right, give it a try. See what you can do. I have one more strategy after this. One more strategy after this. Okay. Anyone still need more time? Still working? Yeah. Oh, sure. Yeah. Mm-hmm. All right, let's go to Alana. So we'll group the first two, right? Group the second two. Was there? Well, actually, I should have asked first. Is there a GCF we could have factored out here? No. Okay. All right. So what'd you take out of that first group? Okay. This way so x squared. And that left behind what?
X plus 7.
Yep. And then from the second group, what'd you take out?
-9
Okay. And that left behind an x
plus 7.
plus 7. Hey, look at that. So we take out that x plus 7. And then we're left behind with an x squared minus 9. Okay, and then you stop there, Alana?
No.
Good, Alana. Well done. What? It factors further, right? To what?
To x plus 7 times x plus 3 times x minus 3.
Yeah, difference of squares. Okay, so that is the final factored form. Okay. Questions on that? All right. Whew. Last strategy here. Yeah, I know. Algebra 2 is boring enough, especially boring when Mr. Wimmeyer goes the entire block with notes. But here we go. All right, so the last kind of situation that we need to kind of be prepared for is like that number 3 from the warm-up, okay? So factoring in quadratic form, okay? In other words, AU squared plus BU plus C, where U is any expression.
You're off the screen.
I'm off the screen. Sorry, thank you. Okay, where U is any expression. Where U is any expression. Okay. So, example. 2p to the 8th plus 10p to the 5th plus 12p squared. Okay. We're going to factor this. Again, go through your tools. Number 1, always, is there a GCF?
Yes.
Yes. What number can I divide out of all of these? 2. What about p? P to the 2, right? So it's 2p squared we're going to take out. Okay. 2p squared out of 2p to the 8th will leave me with p to the 6th. 10p to the 5th, take out 2p squared will leave me with 5p to the 3rd. Okay. And then 12p squared, take out a 2p squared will be just 6, right? Okay. And so we look at what's left over, right? That GCF we factored out, that's good to go, kind of. We look at this, okay, and we look at we think about all the different things we could do. Is there a difference of perfect squares here? No. Is there a sum of perfect squares here? No. Is this a sum or difference of cubes? Well, we kind of have like 2 cubes here that are being added, but then we have this plus 6 as well, which is not a perfect cube. So when you have a sum or difference of cubes, it should be 1 perfect cube plus a perfect cube, or 1 perfect cube minus a perfect cube kind of thing. But we have 3 things, so we really can't use the sum or difference of cubes formula. Can we factor by grouping here? Why not? What's a good clue that grouping is not going to help us here? Odd number of terms, right? 1, 2, 3 terms here. So that's not going to help either. So, but if you look here, if I were to rewrite this, using another set of parentheses here, which sometimes makes things more complicated than it needs to be, but anyway. Okay, this thing is in quadratic form. You see we have something squared plus 5 times that same something plus 6. So, you can think of it kind of like something squared plus 5 times that same something plus 6. And we're going to factor this like it's a quadratic. So it'll be the something times the something to get the something squared there, right? And then these 2 numbers here have to multiply to what? 6 and add to make 5. So what numbers are those? 3 and 2, or 2 and 3, however you want to say it there. So, In this quadratic form where I just have blanks, right, these blanks, it factors to blank plus 2 times blank plus 3. What are filling in my blanks here in my quadratic? What term here is filling in my blank? What is in the place of the blank here in my quadratic? P cubed. Yeah, it's the p cubed there, right? It's the something squared. And then plus the 5 times the same something, right? Something squared plus 5 times the something plus 6. There's your something. There's your something, right? This is the blank. The underline, there's the blank. So in other words, this will factor to be blank plus 2 times the blank plus the 3 there. And where the blank is just the p to the third. Can we factor any further? No. If this 2 were an 8, could we factor further? Yes, because it would be a sum of cubes then, and you could then factor further using your sum of cubes formula. Okay, so watch out for that. But in this case, 2 is not a perfect cube, nor is 3, so they don't factor any further. But they could if they were perfect cubes. All right. Do you want to see another one like that? Yes? Another one? No? Stop the torture, Mr. Witt. I don't care about learning this stuff. I just want it to be done. Gotcha. Well, too bad. We're going to torture you a little bit longer. One more. Okay, because someone said yes. And I'm always going to err on the side. I don't care who said yes. Whoever said yes, thank you. Thank you. Okay, so let's try another one here. Okay, try another one. All right, you tell me. First step, what should we factor out? GT, and in this case, what is that going to be? 4t squared. Okay, so take a 4t squared out of here. I have now t to the 4th. Take a 4t squared out of here. I now have minus 5t squared. Take a 4t squared out of this. I now just have a 6. Okay. So again, we look at this, and we're like, oh man, grouping doesn't work. Oh man, there's no difference of cubes or sum of cubes, although maybe you are glad about that, because difference of cubes and sum of cubes is always a trouble for me to remember how to factor that. Okay? Let's see here. Grouping doesn't work, so that there's not a difference of squares or sum of squares here. All right, so we got to try that back like a quadratic, because it looks like it's a quadratic, right? It's a trinomial, bless you. It's got 3 terms, so let's see what we can do here. If I rewrite this as t squared squared minus 5 parentheses t squared plus 6, right? So in other words, we have those t squareds. Hey, Jonathan, you have a problem? No. Okay. You want to maybe watch those outbursts like that again? Appreciate it. You want to say silly noises and say we're after school or something like that. Okay. So anyway, and otherwise I'll send you the nurse. Sounds like you need to get something checked out. All right. So the blanks here are going to be blank squared minus 5 blank plus 6. Okay. So again, with this factor.
All seniors, please report directly to the auditorium for set today. All seniors, please report directly to the auditorium for set.
So it'll be blank and blank, right? Because blank times blank gives you blank squared. All right. What two numbers multiply 6 and add to negative 5?
-3, -2.
Yeah, negative 3 and negative 2, right? So yeah, in this case. So it'd be blank minus 3, blank minus 2. So 4t squared, blank minus 3. This blank thing I'm kind of just using to help you guys. If it confuses you more, maybe don't use it, right? But okay, and there it is. Can we factor t squared minus 3 at all? No. Can we factor t squared minus 2 at all? No. But if 3 were a 4, you could factor because then it'd be a difference of squares. Okay? Or if this were a 1, right? You could factor because it'd be a difference of squares. That's it. Okay. And John, that's on recording, so you can check it out again if you want to listen to it.